Welcome back. We're going to start in this section talking about inference about two means. Now we're actually going to have to do this in two different ways depending on whether the samples are dependent or independent. So in this section we're just talking about dependent sampling. And remember, dependent samples are also called matched pairs. Now we wish to test hypotheses regarding the mean of the population difference. So in other words, the difference of the two population means. And what we're going to do is we'll randomly select n matched pairs. And for each pair, we compute the difference that we'll call d. So we're going to call the difference of the population means mu sub d. For each pair, we're going to compute the difference, and we're going to work directly with the difference d. So there will be a difference for each pair. So we'll have just the one variable that is itself a difference. Then d bar will be the mean of all the d's. Okay, so each d is a difference. D bar will be the mean of those differences. That's for the sample. We'll have S be the standard deviation of all the differences. Okay, so we're going to do hypothesis tests for these, and then later we'll do a confidence interval. So first of all, let's just talk about the types of hypothesis tests. So the null hypothesis for all of these types of hypothesis tests is going to be that the difference, the average difference between the two populations is 0. So that's for all the types of hypothesis tests. Remember, remember in the null hypothesis always represents no difference, no change, or something of that form. So you're always going to have an equals for your null hypothesis. Okay, then one possible alternate hypothesis is that perhaps that mean difference is actually less than 0. So that would be a left-tailed test. And our approach is going to be to, given some test statistic, and we'll see in a minute that that's going to be a t. Okay, so the test statistic will be a t. We'll call that t naught. We're going to need the area to the left of that test statistic. And you can just glance down the page a bit to see the formula for the test statistic, and we'll come back to that. And the book usually calls that t naught, so I'll go ahead and put a naught in there. And we've seen before that with means we tend to use the t distribution. Okay, so that's true even when we're doing the difference of two means. We're using a t distribution. Okay, let's see. I guess another possible alternate hypothesis would be that the difference between the average difference between the two populations is actually greater than 0. That would be a right-tailed test. So again, we'll compute a test statistic. Then we're going to be using the t distribution. Our test statistic is going to be some number that we call t naught, and then we'll be looking for the p-value or probability area to the right. And then the last possibility is that our alternate hypothesis is that the difference between the populations is not equal to 0, but we're not specifying greater than or less than. This is a two-tailed test, and this is the one that's the most complicated or confusing, whatever you want to call it. We're going to get a test statistic. Now, sometimes the test statistic will be positive, sometimes it will be negative. So I can't just write t naught on either side because I don't know which side. If t naught's positive, it should go here. If t naught's negative, it should go there. Because remember, 0 is right in the middle of the t distribution. So what we do is we kind of since we're being a little abstract here, we just make sure that we've got a positive number on the right side of 0 by putting absolute value bars around the test statistic. So whether it's positive or not, the absolute value of it is positive. Then to make sure that this one is negative, because remember, T naught might come out to be positive. To make sure it's negative, put absolute value bars on to get a positive number, and then stick a minus sign on the front to get then a negative number. And with a two-tailed test, then you're looking for the probability of being, a certain distance away from the mean, from the middle. So you're looking for area out to both sides. And these areas are the same. I'm sorry, I'm not good at drawing things that are not lopsided. So in the picture, it looks like there's more area here, but these are actually exactly the same shape for the t distribution. Okay, again, here's our test statistic. It's a t. Remember, when you're using the t distribution, you have to know the number of degrees of freedom. And as before, the degrees of freedom, so this is the t distribution with the number of degrees of freedom is 1 less than the sample size. And then just a last comment about this method using the t distribution for hypothesis testing here. This method can be used when the sample is random and dependent. We're talking matched pairs here. We won't talk about independent ones until the next section of the book. The difference distribution is normal, or the sample size is greater than or equal to 30, and the sample size is no larger than 5% of the population. So n is less than or equal to 5% of, and capital N is the population size. Okay, so that's those are the introductory remarks we need and formulas we need for hypothesis testing for this type of setup. So I'll end this video here, and in the next one we'll do an example.